So for my experiment of extra credit, I decided to come back to the Alpharetta campus lab and whip out these like Tesla spheres, I think they're called. I know Nikola Tesla has invented, or maybe not invented, but kind of pioneered this kind of stuff. He had giant ones of these in his lab and would generate huge amount of energy and lightning. But this basically uses the process, or the concept of electrostatics, which is right here, as you can see. Here, zoom in. It's electrostatic generator right here. Here, come in. Do you see the electrostatic? And then this is the ground terminal. So basically, this is generating a bunch of electrons that boil up to the metal. The metal is a conductor, so it's all sitting at the edge of it. And then when we turn it on, the static charge will make all the things stand up. Like if you were to wear wool socks and go on a carpet, your hairs would go up. Same concept. And this will generate about 3 kilovolts, I think. So we have to stay very far away from it with a ruler. But in doing so, we can actually see the static shock, which is a lot more intense than, say, you use like wool socks and stuff like that. So we'll highlight that after we film. But for right now, let's see. To increase the speeds on a max, and it's discharged. So wait, to discharge it, you always put this to that. That removes the charge. This is plugged in. All right, so we're gonna turn it on. Let's get it closer. All right, as you can see, we turn the lights off so you can see the charge between it. But it's very aggressive, very violent, and it looks pretty cool. And this is only around 1 to 3 kilovolts, I think the professor said. So if you were to increase the magnitude of voltage, you would see a lot bigger lightning bursts, essentially. So as I was saying, Nikola Tesla, he had this in his lab. It would generate like lightning bursts almost as big as the ones you see in the sky. Just insane amount of electricity running through it, an insane amount of current and stuff like that, big bulbs and stuff. And what he'd do for protection is put himself in a Faraday cage, which is kind of cool. He's using that thing, which is basically a metal box around him to protect himself. And that's the same concept of if there's ever a lightning storm, you get in a car, because if lightning strikes a car, it goes to the outside and the energy is dissipated around instead of going through. So he was able to run all these processes and also be on the ground floor of all of it at the same time. So I'm going to turn the lights back on. And as you can see, the strings are also standing up. 1 second. Yeah. And see, it's also being drawn to that sphere. And that's about it. Later in the video, I'll add another clip where I'll explain more of the science of it using like mathematical equations and stuff like that. But for now, that's it. Alright, I'm back from the lab, and as I said in the video, I would clip to how this actually works behind the scenes. And here is an internal view I found of the electrostatic generator. As you can see, there's a metal dome that cases all the charge, right? All the positive charges out there. Then you have a motor that cranks up a belt, which creates static electric charge. You have insulators on the side, so it just stays maintained. And then also, I found a better picture of it. Yeah, here you go. This is a good picture. And then you have a conductor attaching the electric static charge to the aluminum sphere. Again, covered pulley, more the same. But essentially, that is how it works internally. Alright, so I went over how the internals of the mechanism work, and now I'm kind of giving you more of the theory of how the generator works. So this concept or formula kind of uses Van de Graaff's rule, And basically the theory behind it is you calculate the potential inside the conducting sphere with that formula, where Q is the charge of the big sphere right there, and then the potential of the small sphere, where Q is the charge right there, and the radius in between, or the radius of of that sphere and that sphere. And then all you do is you can calculate the total potential by just doing some algebraic manipulation and essentially subtracting the two together to get the potential difference. It's a pretty simple formula, looks fairly similar to what we'd had been using in class.